because they don't learn this equation, so they don't know what's happening. They're all connected, so be aware of that. Okay, that this is the formula for potential, and since the electron is moving towards this thing, it's losing energy. That's all these values are given negative, and when it goes to that location, it is infinitely far away. So distance to the infinite hoy, potential to key hobe 0, 1 by infinite, right? So that's basically infinitely far away. And if you go beyond that, which I know it doesn't sound right, but infinite beyond you are becoming part of not part of the atom anymore, and that's ionization. Anyways, these are numbers here. Now look at the gaps here. So the gap between these two levels is 4. The gap between these two is 8. The gap between these two is 2. The gap here is 12. The gap there is 14. The gap there is 10, right? Why did I put these gaps here? So listen very carefully. Right. So as I was saying, you have your gaps here. So the gaps are 4, 8, 14, 12, 2, and 10. Do you understand what I'm meaning here? The gaps, right? Now imagine these electrons here are all in the ground state. You want to excite them to higher energy levels, right? The only energy that they will take in are these values here. They will not take any value more or less. And the reason behind that is, I'm going to take 4.1 day. Let's say we do that, right? It can go from here to there because gap to 4. But kottu baki thakbe 0.1, right? What does it do with 0.1? The electron doesn't have anything to do with 0.1. So what it does is it doesn't even transit to that level. However, photoelectric emission, when you give the energy to the electron goes out and it has excess energy. What does it do with that? It becomes K and goes away. Ekhane electron is 0.1 এই shell থাকতে পারবে না. So it doesn't even transit. 3.99 it won't transit. The only time it will transit is if you provide 4. আর কোনো সময় হবে না. Yes. So the thing is that if it's a photon, the photon will just phase through the electron. It won't interact with it. Okay. And if it's an electron that's coming in, the electron will either come and replace it, and that one moves out of it, or it just doesn't interact anymore. It's a build-up. So it doesn't, if it reaches 4, you can't go to 4.1, right? Because you're going from 3.99, 3.9994. So it has transited. Now the 0.1 can't be there anymore. So it doesn't happen. Okay. Same. Electricity works like photons. Like they will have to have the exact energy. They interact or they don't interact. So yeah, these are transitions that take your electron to the top level here. And as the electron goes up, this is very important. How many different ways can it go up? So there's 1, 2, 3, 4, 5, 6 different ways. And these ways are called transition states or transition paths. So the different ways in which your electron can transit to higher levels depends on what? The gaps out there. So for this atom, how many different transition paths are out there? 1, 2, 3, 4, 5, 6. Our in the combination. By the way, like they'll give you maximum like 3 or 4. Because if I make it 5, it becomes much more. Calculator, if you do 20 factorial, or sorry, 5 factorial, that is the number of transition states out there. That's a lot. 1 into 2 into 3 into 4 into 5. I think 120, right? So that's a lot. So anyways, my electron has been excited to a higher energy level. Okay, set the screen. Let's see this. So your electrons have been taken to a high energy level and they're now at an excited state. Excited state mane hocche at this high energy value out there. Now, what we're going to do is we will let them fall back down. That's when the energy is not there anymore, the electrons can't sustain that level and they'll fall back down. As they fall back down, can you predict what are the energies that must be released to fall back down? মানে এখানে হচ্ছে যদি এই ভ্যালুস গুলো নিয়ে they can go up, right? And they're all excited at those levels out there. If they want to fall back down, what's the amount of energy they need to release? The same, exact same, right? So how many different ways can it fall back down? 6, right? So এরকম করে হচ্ছে 1, 2, directly আসবে 3, তারপর intermediate একটা 4, intermediate একটা 5, and আরেকটা intermediate এখানে 6. Each time it goes down, it's releasing energy. The question is, how does it release energy? In what way does it release energy? So yeah, to figure this out, Niels Bohr came up with an idea. So what he did was he took a very high voltage power supply and he connected the terminals, the electrodes, metal electrodes between these two places like that. And there's this very high voltage provided. And this was placed in a chamber. So there was a chamber like that. And what he did was he placed a gas inside the chamber. Okay. It's risky, but he did it. So what he did was he put some gas inside, hydrogen to be precise. Hydrogen should experiment risky. It's very flammable, right? So he put hydrogen gas inside. And what he did was he provided 10,000 volts across it. So really high voltage. And as he provided 10,000 volts across this hydrogen gas in the chamber, he saw that the chamber started to what? Glow. And there was light coming out from the chamber. Okay, so this is very random. You take a chamber, put gas inside it, put 2 high voltage supply across it, they were glowing, like light coming out. But he found that the light is different for different elements. And he found that if you put, let's say, some kind of gas inside, it can turn purple. He used neon. And that's when neon signs became very famous because they can produce these fluorescent colors they have. Certain colors very much low. And turns out the light that he was seeing was because of what? It was because the electrons were falling back down. And as the electrons were falling back down, they were releasing what in the form of energy? Photons. So এখান থেকে যেটা বের হচ্ছিল, photons বের হচ্ছিল. And each transition resulted in a single photon. Okay, one more time. প্রত্যেকটা transition results in a single photon. So, excuse me, I have a question for you, okay? Can you tell me which transition here might produce a red light? Which transition here will produce a red light? মানে কোথা থেকে কোথায় গেলে do you think red light possible? -2 থেকে -10. -10 থেকে -14. Possible, but any other way? 0 to -2. আচ্ছা, so আমি একটু বলি কেমনে এটা বের করতে হয়. So when the transition takes place, right, what happens is your electron is released and the photon is released, sorry. And what's the formula for the energy of a photon? E equals to hf. The E that you see here is going to be what? The gap in energy there, right? So del E is equal to hf. So if my gap is based on the frequency, red light has what frequency? The highest or the lowest of the visible spectrum? Lowest, right? So lowest with the frequency, wouldn't the lowest energy change produce red light? So the lowest energy change is 0 to 2. Based on that, can you predict what might produce the purple light? In fact, ultraviolet produce for a quota. Yes, the biggest one. Okay, so actually ultraviolet light wave, right? Or ultraviolet wave photon. So it goes all the way from here to there, and that produces your ultraviolet photon. And each of these transitions that you see here produces a photon. Now, interestingly, each photon is what to every element? Unique. Okay, so এখানে যে photons গুলো বের হবে will never be released by any other element out there. Full stop. There's no like exception out there. Why is it like that? Why is it that the colors emitted by this element is going to be unique to this element only? Since the nucleus affects the energy level. So like if the little frequencies are given the nucleus, so the jumps are different. So each level is a different color. Right, close. Anyone else wants to try? Different? electron configuration. You have condition different. Aksha. Levels. Hey, collectively, everyone's correct. So let me explain how you word this. So the way you say this is that every element has fixed discrete energy levels, which are what to every element, unique to every element. So when an electron transitions between these energy levels, they produce and they release energies that are what to every element, unique to every element. As a result, the colors happen to be what as well, unique. So when you look at the colors emitted by this, right, it looks something like this. So when the color is like something like that. So if you see here, do you see the colors coming out from here? There's blue, there's orange, there's red, there's green, there's purple, right? And we take this light and we pass it through a diffraction gradient. Now, importantly, do you think you're seeing individual photons or are you seeing the combination? The combination, right? That's why when you see, let's say, barium flame test is like apple green color there. If we actually look inside barium's colors of photons, right? Green ase, red ase, there's purple there, there's yellow there. Sub combined kore, what do you get? The apple green color out there, right? So it turns out, if you look at the elements and you look at the colors they emit, you'll get something like this. এই জিনিসটাকে আমরা বলি হচ্ছে the emission spectrum or emission spectrum. Emission spectrum হচ্ছে whenever you take an element, you heat the element and you allow it to cool down, it gives off light. If you look at the colors emitted by that element, you'll find that the colors are what to that element, unique. And this one that you see here is like the map for hydrogen, for example. So I'll show you some colors out there to like an idea of what I'm talking about. Like how does emission spectra look like? Look at that. So these are typical emission spectra that you get from different elements. So hydrogen, helium, neon, sodium, mercury. Do you see the different colors they emit, right? And these colors can only be emitted by what? These elements. So there's no way, by mistake, hydrogen may emit some other color than it normally does. And that's the reason why we can use this as what? A very definitive way of figuring out what elements are present. So তার জন্য হচ্ছে flame test করা হয়, but এই জিনিসটা ল্যাবে করা খুব complicated. That's why it's like done in very high-end labs out there. And there's something else you probably have learned, the mass spectrometer. Do you know the mass spectrometer? So mass spectrometer is very similar to this, but mass spectrometer uses ratios to find compounds, right? Our ATA tells you exact element available. So this is how we know what stars are made up of. I mean, no one went to the sun and figured out what's made up of hydrogen. It could be made up of anything, right? But we saw the light come from hydrogen. We saw the light come from hydrogen on Earth, and we saw that they're exactly the same color. So what's the sun made up of? Hydrogen. Similarly, whenever you look at some random planet or star out there, and they claim like there's water on it, or there is like, some other element, sulfur on it, right? Venus has sulfur. How do you know that? So Venus' atmosphere থেকে যে লাইটটা বের হয়, Venus-কে দেখা যায়. So Venus থেকে যে লাইটটা আসে, if you put it to a, diffraction gradient, you'll find there are lines showing up there. The lines match which element? Sulfur, oxygen, nitrogen. So now we know that these might be present there. Do you get my point? So yeah, this is called a mass spectrometer. Now, so you'll actually get like a chart that has all the colors in it, then you have to filter them out. So you'll actually get a combination of everything, and then from there, like 554 is for hydrogen, right? So then you look for all the colors of hydrogen, remove that. Then you look for, let's say, nitrogen, remove that, and eventually you'll be able to figure out all the elements present. Okay. Now, এটাকে বলা হচ্ছে emission spectrum. There is a thing that you need to know though. In the nature part of that, do you see there's an intensity versus wavelength graph given here for mercury? So it turns out the intensity at which your radiation is released is not same all the time. Can you tell me what's the implication of that? Question কি বুঝছো? মানে আমরা এখান থেকে ধর হচ্ছে এই লাইট গুলো দিচ্ছে যে পার্পল, ব্লু, cyan, light green, yellow or maybe red, right? But এগুলা কিন্তু intensity সব different. So what's the implication of having different intensity? True, but why would there be variation in intensity for certain colors?
Best place for electrons to be
Close. metal. Atom. আচ্ছা না, it's much more easier. So আমরা এখানে যদি দেখো এই ডায়াগ্রামটার মধ্যে, can you tell me which one is the peak? Yellow. So yellow intensity বেশি, right? What does that mean? Simply put, it means of all the transitions that can take place, which transition happens most often? The yellow one, right? Now it can be important. If your energy source is low in energy, right? Which one will more likely take place? The higher energy ones or the lower energy ones? Lower energy ones, right? So যদি এইটাকে আমি heat করতাম using a very low energy source, right? Can you tell me which intensity would be high? Red, exactly. And if I use a very high energy source, which one would be higher? Violet or blue, right? Can we double this? Because on the astrophysics it allowed there. So there's this thing called a red giant, and there's something called a blue giant. These are different stars out there, right? Red giant is made up of hydrogen. Blue giant is also made up of what? Hydrogen. Then why is one red, one blue? Because red giant is fueled by a very low power source. So তার জন্য এখানে transition গুলো কোনগুলো বেশি হয়? The red. তার জন্য the star appears to be reddish. It's not into full like blazing red. It is reddish, right? Similarly, blue giant is very powerful because it burns its fuel very rapidly. So blue giant এর কোন transition গুলো বেশি হয়? The bluish ones. The blue giant appears what in color? Bluish in color. So that's the reason why, even though the students eventually ask me this question, and wait a second, red giant is made up of hydrogen, blue giant is made up of hydrogen, our sun is made up of hydrogen. Why do they all have different colors? It's because they actually all have the same color, but color মধ্যে certain frequencies are what? Higher in intensity. So এই রুমের মধ্যে দেখতে পারো, I think I talked about this maybe তোমাদের সাথে, a lamp, the tube light here, right? That's also a white color lamp. You find that big panel there is also white color, right? Or random lamps, LED lamps, but they're all white color, but they're not the same white color. There's something that we normally say like cool or warm, like warm white, cool white, right? A warm white মানে কি? In the white part of the spectrum, which color has more intensity? The reds. Are warm or cooler mode, which one has more intensity? The blues. But they're eventually all what color? White, right? So do you understand the difference, right? So the LED, if you can want to make it warmer, what you do is you increase the intensity of the reds or you increase the intensity of the blues. No. Huh? No. Like, are you talking about lamps or stars? Lamps, no, they're all same power. So this one is 40 watts, right? So if it's blue, like warm, cool, or neutral, they're still 40 watts. So it's, the wavelengths, the combination of wavelengths, right? So let's say there are 5 wavelengths out there. In the blue one, the blue gets most energy, and in the red one, the red gets most energy. But overall, what energy do they all produce? In theory, there should have been, but we haven't found yet. No, pink is not a real color. It's artificial color. Yes, there is. So green giant is a thing that does it, but the problem is we'll never see it. Reason হচ্ছে green giant যখন produce হয়, the green spectrum has equal matching with red and blue. So eventually it turns out to appear what in color? White. So that's like our sun. Our sun is actually a greenish giant, but it's because it's all the spectrums are equally spaced out. Yeah, they exist, but they're called light blue.
Okay. So we have equal giants and
There's a nature diagram. The nature diagram to শিখানো হয় না all of those. So you can see all the color spectrums out there of different stars. Right. So are you clear about this? This is called the emission spectrum. So what is emission spectrum? One more time. Emission spectrum is you take your element, right? You heat the element, and the electrons get excited to a higher energy level, and you allow them to cool back down. As they come back down, they release that extra energy in the form of what? Light, but particularly what of light? Photons. And photons have the advantage to the formula is what? E equals to hf. So you have the energy and you have a frequency. Because the gaps are unique, the watt is also unique, the frequency, and they end up emitting what kind of colors, unique colors out there. Okay, so yeah, this is it. This is called emission spectrum. Now there's another spectrum out there, which sometimes ruins the chapter for students. It's called absorption spectrum. কারণ so far আমি যা বুঝাইছি এটা কিন্তু ওরকম কমপ্লিকেটেড হওয়া উচিত না, because it's in O level at Excel. A emission spectrum, absorption spectrum টা একটু different. So সবাই একটু স্ক্রিনে দেখো absorption spectrum টা কেমনে কাজ করে. So just a second. Right. So what we're going to do right now is this. Screen it that way. It's important, okay? I'll take a chamber like this, and inside the chamber, I will place hydrogen gas at a low temperature. So, you know, it's unexcited. Kono glow hocche na. And instead of using heat or electricity, what are we going to use to excite this? Light. Okay? So, আমি কি করব? Light use করব. I'm going to use white light. And যখন white light use করা হবে, it's basically the whole spectrum, right? There's a name for this thing. Physics, there's a name for this spectrum. It's called the continuous spectrum. So continuous spectrum advantages, it contains which colors? All imaginable colors out there, okay, except for the fake ones, like pink. Pink is not a real color. So the thing is, I'll show you the spectrum. There's no pink in it. Pink is from combination. There are other combinations out there. But if you're talking about true colors, right? Quite a color. Do you know how many colors are out there? 3. No. 3 the primary color, RGB. But how many actual colors are out there? That's actually right. But how many can you see? No, human there are limits, and that's how you know, different monitors and screens and everything has 60. No. Acha, তোমাদেরকে দেখাই. There's a reason I'm showing this. তোমাদেরকে বোঝানোর চেষ্টা করি কি এটা. এই যে এদিকে দেখো, as I take this, it's called a color wheel. Color wheel ki, I don't think you have seen one. Color wheel is basically this thing I'm doing right now. So as I'm going from left to right, there are different colors showing up here, right? How many possible colors are out there? There are computer science shikso, I don't know shikso naki. Each of these colors actually has a code, a hex code. Oy je niche code ta dekhte partecho, a color picker use kore I can pick up the color code. So every color has a code. So there must be some limited number out there. Infinite hote pare na. So do you know how many are out there? Right, so the answer is 256 million. That's what screens can reproduce. So tomorrow screen mode 256 million colors dekhano jay. Our eyes can't pick up all of them because we have limited number of rods and cones. There are these sensors that pick up color, right? Why am I saying this? It's because in this spectrum that I have here, you have every imaginable color out there, and that's infinite, because every single frequency you can imagine is a what here? Color, right? So let's say I pick a frequency 410, তারপর 0 0 0 0 0 এরকম করে করে যদি one day doesn't this become a unique color? So এরকম করে করে how many possibilities are out there? Infinite, right? So the thing that I'm trying to make clear here is that the energy available in a white light is all the energy you can imagine, because you know all the colors are available. But hydrogen ki সব color দরকার? Hydrogen ki সব energy দরকার? No, right? So if you go back to here, what are the energies that hydrogen only needed here? 4, 8, 14, 12, 2, and 10. Is there any other color that it needs to absorb? No, right? So if you pass this white light through hydrogen, the white light passes through hydrogen, and as it goes through the hydrogen will pick out certain colors from here, which can help it excite, right? Once it comes out from here, you'll find notice that there are some white lines showing up here. Can anyone tell me why are these white lines there? Yes, these were the colors that hydrogen absorbed, and hydrogen has nothing to do with the other colors. It only absorbs the colors it needs. And this spectrum that you get here, is known as a what spectrum? An absorption spectrum. So absorption spectrum is the opposite of emission spectrum. Emission spectrum, you only get the colors that are emitted. Absorption spectrum, you get all the colors except for the ones that are emitted. You get my point? So you can a diagram better. Look at this. This is the emission spectrum for hydrogen. So it's only producing 410, 434, 486, 656. Our color produced for it. This is the what spectrum? emission spectrum. If I go to the absorption spectrum, you'll find that all the colors are available except for what? Those 4 colors are missing. Why are those 4 colors missing? Because the hydrogen took those out for you. So there's emission spectrum, there's absorption spectrum. You get my point? Now, why do we learn this? Mane, Itaito was doing its job pretty well, right? Why do we need absorption spectrum? So it turns out the light from the sun is actually an absorption spectrum, not an emission spectrum. So ETA was this very groundbreaking discovery back in the 1800s. No answer though. They they discovered that if you take a prism, right? Newton, Young, the Young modulus Young, ওরা সব একটা experiment করছিল where they send white light through a prism, right? And they put a screen here. And don't you get the rainbow part of the spectrum there? So they saw the rainbow part of the spectrum. But when they looked under a microscope, they found something strange. They found within the spectrum, there were some dark lines out there. Some colors were missing. And back then, obviously, we didn't even know electrons existed. So they had no clue ki hochilo. But they recorded that information, that whenever they saw the light from the sun, they found that all the colors are available, except for certain places. What did they find? Black dark lines. Why are there dark lines? Those are the colors that were absorbed by what? The sun, before the light reached us. So why does the sun produce an absorption spectrum? Let me explain. So if you look at the sun and its structure, does anyone know where is the energy of the sun generated? Only at the core, okay? And fun fact for you, the light that's generated in the core of the sun takes 150 million years to reach the surface. It's not coming out right away. Even though light travels at the speed of light, right? The light from the center, right, actually has a journey that takes almost 150 million years to eventually reach the surface. Because it's a mess out there. And that's like, so much particles moving around, the photons get trapped inside, and they're trapped for millions of years. Eventually, they make their way out. Now, what happens is, যখন এই core থেকে হচ্ছে energy release করা হচ্ছে, it's in the form of gamma radiation, like high intensity radiation. Okay, that's the energy released from the core. As this radiation passes through the hydrogen in the surface, what does the hydrogen do from those energy? Absorbs them, right? So এখান থেকে যে লাইটটা যাচ্ছে, ওইখান থেকে hydrogen কি করবে? It will keep some of the photons for itself, and the rest of them will be emitted by the star, and that's what reaches the earth. So when we get the light at earth, right, we're actually getting the light after what has been removed from the light, the photons that hydrogen needed. And that's why what do we get on earth? An emission spectrum or an absorption spectrum? Absorption. Okay, so it's I think 3 before market questions জিজ্ঞেস করে এই চ্যাপ্টার সুবিধা কি, the questions are very repeatable, standard, বারবার একই টাইপের জিনিস জিজ্ঞেস করে. Okay, so yeah, that's the reason why we get an absorption spectrum from the stars. Because it has every color except for certain colors, right? So yeah, this is the absorption spectrum out there, and there is supposed to be a follow-up question. I'll wait for the question. There's a gap in what I said. Don't figure out করতে হবে and আসতে হবে class 9 এর বাচ্চারা এখনো পারবে না কেন? So আমি বুঝলাম যে হচ্ছে এখানে absorption spectrum হচ্ছে, and there are certain colors missing here, right? কেন missing এগুলা? Because we have sun যে hydrogen গ্যাসটা এই কালার গুলোকে absorb করছে, বাকি যে লাইটটা ওইটা আর্থে রিচ করছে. So আর্থে যখন আমরা লাইটটা পাই, we get an absorption spectrum with some dark lines out there, because those are the colors that the sun has absorbed. I've said this so far. There's something strange in what I said. What to figure out করতে হবে. So ask me the right question. Earth atmosphere light can disperse করে, spread করে দেয়, but কোনো color miss হয় না. That's the reason why the sky is blue and the surface is orange. That's why the sky is blue. I mean, the light gets dispersed. The blue is at the top, the red is at the bottom. Yeah, right. Okay, that's the thing. You should find what's missing here and ask me. Because what's missing, I can't. I'm thinking for you. Missing, right? Yeah, I mean, if there's no light, shouldn't it be black? Why should it be white? Why do you have all the colors present there, right? But that's not the question I was looking for. আর কিছু? Oh, so sun's surface is 99.9999% hydrogen. Like the helium is so limited out there, you wouldn't even detect it.
Body of the hydrogen releases some of the energy as photons.
The colors back again. That's the question. Okay, so the question is that তোমার এখানে hydrogen তো excited হচ্ছে, and at a point wouldn't it release back the light? As it releases back the light, wouldn't these again get filled up? So shouldn't we get the whole thing again? Why are there gaps out there? Very close. So the correct answer is, listen to this. জিজ্ঞেস করতে পারে ওরা. So when the sun has light passing through it, the hydrogen absorbs it, right? And the hydrogen has the electrons excited, and the rest of the light reaches you. But then hydrogeনের যে লাইটটা ওটা কি করবে? Electrons গুলো নিচে চলে যাবে. It will give back out those light. But which way does it give it? Does it give it back to you, or does it give it back everywhere? Everywhere. তার জন্য intensity drop হয়. And the right term is not dark lines. It's basically lower intensities. So যেটা তুমি যদি real life এ দেখো, এখানে black line দেখবে না. এখানে কি notice করবা? There's actually orange, but orange একটু dim. Dim কেন? Because যে orangeটা missing ছিল, পুরোটা কি তোমাকে ফেরত দেওয়া হচ্ছে? না তো, because isn't it dispersed everywhere? So you do get the orange back, but what amount of it? Much lower amount of it. That's why that place appears what? Darker. ওরা কিন্তু কোনদিন বলে নাই black lines out there. Black lines যদি হতো তার মধ্যে কিছুই আসে না. The correct term was darkened lines out there. Okay, so yeah, the reason I put the black lines here is to put my point forward. Otherwise, you go like there's orange already there. What you're talking about, right? So yeah, the black lines are basically what they saw. Oh, it's still there. It's just going everywhere else because the electrons are absorbed in the energy and they're excited, right? And when they release them, which way do they release them? Every direction. But you're anticipating all of them to come to you. So তার জন্য তোমার দিকে আসে, your intensity কি হয়ে যায়, কমে যায়. Okay, so এটা যদি there's a YouTube video, I'll link it for you guys. ওইখানে দেখবা, if you're looking at this live, right, flicker করে. কেন flicker করে? Because the intensity তো constant না, fluctuate করতেছে, বা আসে যায়, বাড়ে কমে, but দেখবা যে there are places যেখানে purple lines গুলো ওরকম like missing দেখা যাচ্ছে. Okay, so yeah, this is called absorption spectrum. What happens when you take an absorption spectrum and merge it with the emission spectrum? Yeah, what is it called? Continuous spectrum. মানে যে আমি যদি এটা নেই, if I take this and if I place it here, যদি properly overlap করতে পারি, wouldn't I get the whole thing, like the full entire spectrum like that? What is that spectrum called? Continuous spectrum, right? And that is the topic. Okay, মানে এই টপিকটা একটু কি ছোট একটা জিনিস, এখানে আর বেশি কিছু নাই. So I will give you some notes and discuss those. But তার আগে, do you have any questions? After all the borrow, yes.
So all stars have the absorption spectrum.
Yes.
So when we see a blue giant, are they giving the red and yellow parts?
Are they giving the red and
Are
yellow?
they giving the yellow and red parts? Are we mostly seeing the blue parts?
You've seen the blue parts. So that's why it's a blue giant, because the blue has higher intensity. In astrophysics, we learn there's this thing called the black body radiation. It's just this idea where the curve tells you what color is what temperature. Wien's displacement law বলে, ওইটা দিয়ে বুঝানো আর easier হবে. বলো, আর কোনো question? মানে এই চ্যাপ্টারটা, হ্যাঁ, কোয়ান্টাম ফিজিক্সটা. Okay, let me show you some of these. Okay, let's do flame test. একটু দিকে দেখো. So I'm going to take sodium here and put it in the flame. দেখো কি হয়, একটু উপরে observe করো. উপরে দেখছো there is this spectrum that you can see at the top, the whole color spectrum. So there goes sodium. So sodium যখন এখানে রাখলাম, electrons গুলো যে excited হয়ে যাচ্ছে, ওরা যখন drop back করে, what are they releasing? light photon, and we gapta produces that particular frequency out there. And let's go for the other sodium here, fluoride. এটাতেও হচ্ছে আর একটা লাইট বের হচ্ছে, লিথিয়ামে যায়। So lithium is supposed to give you what? Red, right? But যদি উপরে চেক করো, I don't know if you can see it, দেখা যাচ্ছে উপরে they're not actually 3 colors, or আমি দেখতে পাচ্ছি না। Can you see there are 4 colors out there? 6টা, 1 2 3 4 5. Acha, my point is, why are there so many colors? Yeah, there are different transitions happening out there, right? So currently orange ta beshi hocche, but majhe majhe some other color shows up, right? Majhe majhe those colors show up. That's why you'll find the color from sodium or lithium here flickers. Have you done flame test? So flame test যদি দেখো, is it like a very consistent color or does it fluctuate? Yeah, it's a nightmare actually. But fluctuate, they cannot fluctuate for it because not all the electrons are doing the same transition. There's like a whole range of it. The intensity varies, right? Let's go for strontium. Do you know what the color of strontium is when test? No? Or red? But look at the like spectral analysis of it. Do you see how many colors have been emitted? There's a lot of them, right? Now, সবসময় কি সবগুলো হচ্ছে নাকি some of them are being emitted sometimes? Yeah, so overall দেখবে একটা flicker হয়। তোমাদের potassium দেখাই দিই before I end. That's the lilac, but it's not really lilac. Lilac is not a real color. So উপরে তুমি যদি combinationটা দেখো, that's what lilac is. All those wavelengths out there combined together. Okay? Hey, class শেষ হয়ে যাচ্ছে তোমরা? It's like no, that's. Oh, before I end, I'm going to show you a lot of other things. About magnesium does white, phosphorus does white. Yes. So if you look at the spectrum of magnesium, it has the 7 colors of rainbow, and they're almost all of them like very evenly spread out in equal intensity. So that's why they appear like that. So absorption and emission spectrum. Let's see this. That's UV light. What is that? Snake.io. Oh, sorry. I think but fireworks. Fireworks are basically flame tests. So whenever you have a firework and you see a color, now that you are done with your school physics and chemistry, you should be able to figure out what the elements are. So whenever you see a red color firework, it's lithium. Then it's strontium. So yeah, these I think chemistry the shikano got that. Don't you learn about fireworks in chemistry? Oh, why not? But there used to be in our time, like what combinations would give like what kind of combustion in colors? No? Oh, that's organic. Gunpowder can be no? What? You're missing out. Acha, it starts with fertilizer, but then we go to gunpowder. Acha, anyways, maybe yeah. Acha, anyways, our next class we'll start nuclear physics. Our next topic. Next class will be till 5:30.
Yeah.